Okay, I'm going to show you how to do some of your homework problems. The first page in your homework packet has to really go back to factored label method. So I'm going to show you how to set them up. We're going to use different units than we've done in the past. We're going to use nanometers. So I wrote up here that 1 nanometer is equal to 1 times 10 to the negative 9 meters. I have hertz over here, so I want to say we're going to use megahertz a lot. So 1 megahertz is equal to, so here's a mega, and I'm going to go to base because the base would be a hertz. I'm going to go 6 places to the right. So 1 times 10 to the 6 hertz. So I'm going to show you a couple examples, and then I'm going to go to a couple problems and show you how to do those. So it says, how many meters are in 780 nanometers? So set it up like I showed you before, 780 nanometers. And you remember what has to go on the bottom because you want it to cancel out. So I want a nanometer to go on the bottom. So I'm going to put, if you look up here, I have 1 nanometer. So 1 nanometer is 1 times 10 to the negative 9 meters. So nanometers cancel out. So I'm going to multiply them. So if I take 780 times 1 double E to the negative 9, that means I have 7.8 times 10 to the negative 7 meters. That is how many meters are in, that's how many meters are in 780 nanometers. So, same thing before, number 2, use the same conversion factor. If I look and I go on down, so let's look at hertz number 6. How many hertz are in 105.7 megahertz? Well, remember, hertz is a frequency, and megahertz, and you've probably heard it, like you've heard like 102.7, 101.9. Those are megahertz. Those are the frequencies. So if I say 105.7 megahertz, and if I go back up and I look at my conversion factor, so 1 megahertz, so I'm going to put that on the bottom, is 1 times 10 to the 6 hertz. So if I cancel that out, I get rid of megahertz. So if I say 105.7 times 1 double E to the 6, then you're going to see it's going to be a really big number. So I'm going to put it in scientific notation. So it's going to be 1.057 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8 hertz. So those are some examples. These are just factored label. So let's go on and talk about light calculations. So I talked about this in the notes a little bit, but if you look, these are the 2 main formulas you're going to use. You're going to use C is equal to wavelength times frequency. The backwards upside down Y is wavelength. And then E is equal to H times nu. H times Planck's constant. H is Planck's constant, nu is frequency. So the only relationship between these two formulas has to do with frequency. So I'm going to skip this page. I'm going to show you how to start on this page here. So it says the wavelength of the green light from a traffic signal is 5.22 times 10 to the negative 7 meters. What is the frequency? So it gives me wavelength, because wavelength is always in meters, and frequency, and it wants to know what the frequency. So I'm going to use this equation here. You could use the triangle. It's always very helpful. So C, and this is lambda, which is wavelength, times nu. So I'm trying to find the frequency. So if you cover up frequency is equal to C over the wavelength, lambda. Remember, C is a constant. It never changes. So it's always going to be 3.00 times 10 to the 8 meters per second divided by the wavelength. Well, the wavelength's already in meters, which is good, because if it wasn't in meters and it was in nanometers, you have to convert it first. So you're going to do 5.22 times 10 to the negative 7 meters. Okay, what cancels out? Meters. So I'm trying to find frequency. Remember, units for frequency is 1 over a second or hertz. So 3.00 second e to the 8 divided by 5.22 shift e to the negative 7. So 3 sig figs. So I have 5.74 times 10 to the 14, and we're going to say hertz, or 1 over a second. That's your answer. So you could also say 1 over a second, or you could say Hz. They both would be perfectly fine. I'm going to show you another example. It has to do, now you're given hertz. It says the blue color of the sky from the scattering of light by air molecules. The blue light has a frequency of 7.5 times 10 to the 14th. What is the wavelength? So, again, using the triangle, and if you're trying to find wavelength, cover up wavelength. That's the backwards upside down y. So it's c over frequency. So wavelength is c over frequency. So C is 3.00 times 10 to the 8 meters per second divided by 7.5 times 10 to the 14th, 1 over a second. Okay? So the only thing you have left is meters. So 3.00 second e to the 8th dividing by 7.5 second e to the 14th. So when you cancel out seconds, the only thing you have left is 4.0 times 10 to the negative 7 meters. That's what your wavelength is. Okay, so that shows you 2 examples how to do frequency and wavelength. So let's look at another problem. Let's look number 6. It says yellow color in fireworks are due to 589 nanometers, or they went ahead and converted it 5.89 times 10 to the negative 7 meters. If I give it to you in nanometers, you're going to have to do the calculation to put it into meters. How much energy is giving off? Well, this is wavelength right here. So in order to find energy, I have to go from wavelength to frequency to energy. So to find frequency is equal to C over the wavelength. So 3.00 times 10 to the 8 meters per second divided by the wavelength, which is 5.89 times 10 to the negative 7 meters. So when I do that, 3.00 second e to the 8 divided by 5.89 second e to the negative 7. So when I do the math, my wavelength is 5.09 times 10 to the 14 hertz. So cancel out meters, it's going to be 1 over a second. Or hertz. They mean the same thing. So once I have frequency, now I can find energy because I can use the formula E is equal to H times nu. So E is energy. H is Planck's constant. 6.626 times 10 to the negative 34 joules times a second. times 5.09 times 10 to the 14, 1 over a second. Cancel out seconds. And so when you multiply them, so 6.626, shift E to the negative 34 times 5.09, shift E to the 14. So cancel out seconds, and then it is 3 sig figs, 3.37 times 10 to the negative 19 joules. And that's what it would be in energy. So that's all I'm going to talk about tonight, but those are some examples of how to do energy, frequency, and wavelength problems.